Welcome, ladies and gentlemen, to the Free Response Question Review. In today's episode, we will be discussing the 2009 Calculus Bc Frq number 5, which also made a cameo appearance on the Calculus AB test of the exact same year. The problem reads, let f be a function that is twice differentiable for all real numbers. The table above gives values for f for selected points on the closed interval 2 to 13. It's a typical table problem. We will handle it accordingly, except for part D. That gets a little bit weird, but we will handle that guy appropriately. Part A says estimate f prime of 4, show the work that leads to the answer. Pretty simple. The highest level of math needed to answer part A will be integrated 1. In order to figure out f prime of 4, I'm going to say, hey, that's approximately f of 5 minus f of 3 over 5 minus 3. Which ends up becoming negative 2 minus 4 over 2. And actually, at this point, you can go and leave it right there just to not simplify it, but if we did simplify it, it would become negative 3. All right, let's take a look at part B. Pretty simple way to start off the problem. Part B, it says evaluate the integral from 2 to 13 of 3 minus 5 times f prime of x dx, and then show the work that leads to the answer. So if we're going to evaluate an integral and it's being separated by subtraction, my personal style is I like to separate the integral. And I just do this because I see shapes easier when I do it like this. Of course, it's all a personal style, so it's up to you on how you decide to do it. 3 is really just a horizontal line, and since the limits of integration are from 2 to 13, 2 here and 13 here, that gives me a base of 11 and a height of 3, and that gets me 33. And then I'm going to minus 5. This guy here, this integral just on its own, this integral will be subject to our good old buddy, the first fundamental theorem of calculus, which is going to be f of x on 2 to 13 with a 5 on the outside. And then when I evaluate that f of x on 2 to 13, that's just going to be f of 13 minus f of 2. So from here we just have to figure out what these numbers are. Well, what's f of 13? Well, f of 13 is 6. F of 2 is 1. So again, I could just leave it like that if I wanted to. Leave it as 33 minus 5 parentheses 6 minus 1. But at the end of the day, if you decide to simplify it, you will end up getting 8 as your answer. So far, it seems like a pretty straightforward FRQ. We haven't gotten to D yet, but we will. When it comes to C, it's a left-handed Riemann sum, so we will take care of that. It says, use a left-handed Riemann sum with subintervals indicated by the data in the table to approximate the integral from 2 to 13 of f of x dx. So my personal style, I like to graph, and I'm hoping you have your prep book right in front of you because I don't want to keep scrolling back and forth. But I like to graph my table problems. I'm just going to put these points in here. 2 goes to 1, 3 goes to 4, 5 goes to negative 2, 8 goes to 3, and 13 goes to 6. And it's a left-handed Riemann sum, so all of my rectangles will have their heights pulled from the left side of the rectangles. So I'll go and just draw those in, and I'm actually going to go and highlight those rectangles in a, not the rectangles, but the left sides in a different color. Remember, a left-handed sum pulls the heights from the left side, so all of the heights are going to be basted in ketchup. And so from here we are, and here we are. So after we have all that, we're just going to go ahead and add them all up. So it's going to be my first base here is a base of 1 with a height of 1. And then my base here is 2 with a height of 4. My base here is 3 with a height of negative 2. And my last base is 5 with a height of 3. And again, you can go and just leave it like this. Remember, on the AP exam, they're not going to expect you to simplify. But if you wanted to simplify the whole thing, you would get 18. So hopefully A, B, and C are good. It's really D that really goes down in infamy with this problem here. If you need to, go and pause and get these answers down, and we will come back with D. I'm going to go ahead and clean up the board and close my door because the birds and the dogs are barking and chirping like crazy. Okay, I don't know if you guys could hear that in the background, but yeah, there were some birds that were going really, really crazy and a dog that wouldn't stop barking, so I have no idea what's going on out there, but let's just take care of D. It says, suppose f prime of 5 is equal to 3, and that f double prime of x is less than 0 for all x in the closed interval from 5 to 8. Use the tangent line to the graph at x equals 5 to show that f of 7 is less than or equal to 4, and use the secant line of f on 5 to 8 to show that f of 7 is greater than 4/3. Okay, really weird question, a lot of words. I could totally see someone being very easily threatened by this question here. Let's break down the pieces that are important real quick. The most critical piece of information here is this guy here. The fact that f double prime of x is less than 0. What that tells me is that this graph is concave down. Right, concave down. And since f prime of 5 is 3, that means that we're increasing. So increasing concave down looks like this. The graph is going to look like this at x equals 5. Okay? And so, and actually from 5 to 8, we don't know exactly what's happening, but we do know that we're definitely concave down. So it's possible that beyond 5 we could be decreasing, but as long as it's concave down, it doesn't really matter what's happening. And that's going to play more of a role in the secant line part of the question here. But concave down really is the piece that you guys need to pay attention to. Okay, so to start off part D, it gives me a slope at 5. And so from here, I'm going to go ahead and find out what my tangent line is, because I know I have a point at 5. The table told me that. I've got a point at 5 here. It's 5, negative 2. So I can write that down. I can say y plus 2 is equal to some kind of x minus 5, and we know that this guy is 3 because the slope of the graph is 3 at that point in time. They told me that. And so what I'm going to do is I'm going to bust out a tool that they're not expecting me to see. And the reason why I knew to use this tool is because I'm trying to find out a value, I'm trying to approximate a value of a function based on a tangent line. Well, this idea is what you guys know as linear approximation. So what I'm going to do is I'm going to go ahead and plug in the value of 7 into x. So y is equal to 3, 7 minus 5 minus 2. And what I get from all that is that y equals 4. So what is that telling me? It's telling me that based on my linear approximation, f of 7 is approximately equal to 4. Again, it's an approximation because it's a linear, because we're using a line to approximate the value of a curve. Well, how do I use that to show that f of 7 would be less than or equal to 4? Well, it's easy. What I do is I say, and I'm actually going to type this out, I'm going to say f double prime of x is concave down. Oh no, what am I saying? F double prime of x is less than 0 on 5 to 8, making f concave down on that interval. And then I say, therefore, our linear approximation is an overestimate. Which means, so the most f of 7 could equal is 4. In other words, guys, and you don't even have to write down that so part. In other words, that's what I'm thinking, but here's what it's saying. F of 7 at most can be 4. I hope that makes sense. We just used linear approximation and concavity. Let's talk about the secant line part, though. The secant line part's a little more confusing because we rarely use secant lines for anything. But what I'm going to do is I'm going to actually punch in the secant line into my equation also. So in order to do that, let's find the equation of the secant line. So the secant line is going to be f of 8 minus f of 5 over 8 minus 5. That gets me a 3 on the bottom. And on the top, that's going to get me 5/3. Now going back to integrated 1, we can actually use whatever points we want to write the equation of the secant line. We could use the point at x equals 8 or the point at x equals 5. I'll go ahead and use the point at x equals 5, and the reason why is because he's easier. We've already written the tangent line there. So that means that I've got now instead my secant line equation is going to be y plus 2 is equal to 5/3 and then x minus 5. Now what I'm going to do is I'm going to plug in 7 into my secant line as well, because remember, I'm going to use the secant line to now approximate the value of 7. So what is that? That's going to be y equals 5/3 times 7 minus 5 minus, and I suspect I'm going to get a fraction here, so I'm going to go and just call them common denominator. So I get 10/3 minus 6/3, which is 4/3. Okay, so according to my secant line, I get 4/3 if I plug it in. But remember, the idea is that I'm trying to show that f of 7 is greater than 4/3. So at the end of the day, f of 7 is going to be less than 4, but greater than 4/3. But how do I know that to be sure based on the secant line? Well, one of the consequences of a secant line, it has to do with the fact that I drew these. So the idea behind it is that based on the concavity of the graph, you have to know how a secant line is going to behave. So a secant line, or rather a concave down graph, regardless of the increasing versus decreasing behavior, a secant line will always be below, and I apologize for the non-straightness of that line, will always be below the graph. Which means your value, so imagine this is at 7, your graphical value will always be above the secant line. So that's what you write down. What you say is you say that f is concave down on 5 to 8, making the secant line below the graph. Therefore, f of 7 must be greater than or equal to 4/3. So really, really odd problem for part D. I hope that makes sense. As always, post in the comments any questions or comments. If you have anything that doesn't make any sense, let me know and we will clarify it. And I will see you all in the next episode.